Okay, we are continuing with the revision of functions, which is now we are going to question number 5. So we'll have question 4 most of the time, question 5, and sometimes we can go to question 6 to do all these functions, depending on the examiner, the person who have set the paper. So this time we had taken another one on previous examination, which is now in question 5. This is very straightforward question, but it needs you to be focused. Question 5.1. It says, on the same set of x's, sketch the graphs of f and g. Take note of the same set of x's, because if you draw them separately, you did not actually answer the question. Clearly indicate all x's with intercepts and turning points. So you have to show all the x-intercepts and also the turning point. The equation given are f of x equals x squared minus 5x minus 14. Now you should have a plan in your mind to say this is a parabolic graph and it has a positive value of a. In that case, it means I'll have a smiley shape. It means that my graph will look up. If it doesn't do that, something is wrong. Now the next equation is g of x equals 2x minus 14. This is strictly a straight line, and this straight line also, it is a positive straight line that will go using your left slanter to the right, not your right to the left. Okay, so let's draw them, because in 5.1 they said you must draw them on the same set of x's. So we're gonna do the Cartesian plane. As usually when you have to draw the graph, you must have a Cartesian plane. So remember, my graphs might not be up to scale, but I will try by all means to make it visible or understandable for you. So let's put our Cartesian plane with a ruler so it's nicely drawn. We have the labels as x and y axis, which is our line. Now, every time you must draw a graph matrix, you must make sure that you find your x-intercept and your y-intercept. That goes for every graph. However, with the parabola, you have to find the turning point for you to be able to draw. So someone will be surprised, why is this 6 marks? 6 marks is because you have to go as far as finding many things. So we're gonna do that first. To start with the 1 for f of x, which is the parabola, we'll say f of x is equals to x squared minus 5x minus 14. So let's find the x and y intercept so we can plot. Our y-intercept, we are going to let x to be equals to 0 so we can find y. Remember, f of 0 is our y, so we'll have to put 0 wherever we see x. And this is our equation. With f of 0 is equals to 0 squared minus 5 times 0 minus 14. And that makes our y-intercept to be minus 14. So f of 0 is minus 14. In other words, in a Cartesian plane, you will go and find where minus 14 is. So say this is minus 7 and make this one a minus 14. So this is where we will have our equation or our x-intercept for the parabola graph. To find the x-intercept, we will have to let our y to be equals to 0. By doing that, we are going to left with something that we need to factorize or something that is factorizable. If not factorizable, remember that you can still use a quadratic formula to find the solution. So if it can be factorizable, we can quickly factorize. So let's see, if I say x minus 7 and x plus 2 in my brackets, I think this is factorizable, so we can do that. It means that x is equals to 7 or x is equals to minus 2. So now this is our x-intercept. So if this is minus 2 and this side will have, we need a 7, so it's 2, 4, 6. Our 7 is somewhere here, so have a 7 there. That is our x-intercept. Now we are left with one thing, which is a turning point. To find a turning point matrix, you have to use a formula of x equals to a negative b divided by 2a. Remember, the b is the value that is attached to x. So that is a negative 5. So it's going to be negative 5. And a is the one that is attached to x squared. That is 1 in this case. So it means that our turning point, therefore, it's going to be a positive 5 over 2 for x value. Okay, a positive 5 over 2 can be written as a fraction, can be written as a mixed fraction, which is 2 whole number 1 over 2. And after finding the x, we need to find the y. Remember to take the x value and substitute it on the original equation, which is f of x. So now it will be f of 5 over 2 equals 5 over 2 squared minus 5 times 5 over 2 minus 14. And you can simply take your calculator and put it in. In that way, you get it simpler and faster. You don't have to put an equal sign. You can just punch it as it is on the calculator, and then you'll get it right. So let's punch them. It's let's quickly put it in and get the solution. Will be minus 14. It gives us a negative 81 over 4. It's a negative 81 over 4. If we need to check, that is in a fraction is negative 20,25. And that is below the 14. So let's say this is our negative 20 over 25 there. Negative 20.25, which is 81 over 4. That's where we have it. And the x, it's going to be 5 over 2, which is 2.5. 5 over 2, it is 2.5. So that means it's between 2 and 3. Remember our scale, this is where 2 is, and 3 is going to be here, so 2.5 is there. Let's go down so that we can be able to put our point of a turning point. Remember, your important points are the turning point, the x-intercepts, and in that way, your graph will look like that. That is your parabola graph, which is f of x. We have drawn the f of x, nice and smooth, and we can label the point that we know or what we have found, especially the turning point. There is our turning point in negative 81 over 4 as y, and for x is 5 over 2. So we are done with the parabola. Now, if we have to draw the g of x, remember g of x is a straight line. So still, the rules are the same for a straight line, for a parabola, for hyperbola, and all the types of graphs. X-intercept and y-intercept, we get it the same. So we let x to be 0 to find the y-intercept. So that means that our g of x, or the g of 0, will be minus 14. In other words, your graph must pass through minus 14. To find the x-intercept, we will let y to be equals to 0. So we have 2x minus 14 equals 0. So that is 2x equals to 14, which is now x equals 7 through dividing both sides by 2. So it's still going to pass through a 7. So can you see that they all have a common point, which is the intersections of x and y? A minus 14 and a 7. Just put a ruler there and nicely put a line that will give you your equation or your graph of g of x. And that is where your 6 marks lies. Very smooth and straightforward. We are left with one question to be answered in this one. The last question is to determine the equation of the tangent to f, where x is equals to 2 whole number 1 over 14. Okay, matrix, let's move to the Look at the solutions here. We had our x equals to 7 and x is equals to minus 2. And the 7 are sharing with the other one for the x of a straight line. Can you see the red one is for a straight line and the blue information is for the parabola? Of course, we are told to write the two, to draw the two equations on the same set of x's. So this is what you're supposed to do. Now the last question, which is 5.2, we are going to write it by the side. That is where 5.2 is. Look at what they are doing. To get 2 marks, they are saying determine the equation of the tangent to f at x is equals to 2 whole number 1 over 4. If you punch that thing on a calculator, you will see that that is the same as 5 over 2. And the tangent thereafter is a line that can come through this line, this point of the turning point. So for that matter, it means your y, or the equation therefore, will be a straight line that is y is equals to negative 81 over 4. And they give you 2 marks just by recognizing that. Can you see how simple that is? Okay, that is the last part of the question, and thank you. Okay, grade 12, we are continuing with the revision of functions, and now we are going to another question. Remember, these questions comes a little bit different in a way, but they are the same with the same content. What you need to do is just to understand your basics, and you will all go well. Okay, we are going to question 5 again. In this case, a graph has been drawn for you. Unlike the first ones, you were supposed to draw the graph. Now we are still in question 5. Now let's see what this question 5 is saying to us. This is the graph that is saying, they said to us, the graph of f of x is equals to a to the exponent x, where a is greater than 1, is shown below. T is a point where there's 2 and 9. Remember, 2 is the x value and 9 is the y value on the graph. It lies on f, which is on the graph. So you can see there it is. They said in 5.1, calculate the value of a. You already have been given a point, so it is not that difficult for you to calculate the value of a. In 5.1, we are going to calculate the value of a. Let's copy the equation down. F of x is equals to a to the exponent x. And bear in mind that your value of a must be positive and greater than 1. It cannot be 1, but it has to be greater than 1. Okay, remember we are given the point t, which is 2 and 9. We must substitute that. And we know, or we have said that 2 represent the x point and 9 represent the y point. So y point in this case is our f of x. It means we are going to substitute those two, and then we can be able to find our a. So let's do that. F of x is going to be 9 equals a, and our x is 2. Now, for us to get it correct, it means that we have to change 9 to have the power of 2. Now, in an exponential rules or in exponent from lower grade, we know that 9 can also be written as 3 to the exponent 2, which now it's equals to a to the exponent 2. As our exponent are the same and our bases are not the same, we are going to therefore ignore or disregard our exponent and focus on the basis. Therefore, a is going to be equals to 3, and that is the solution for this question, and it's 2 marks. If you look at it, the 2 marks is direct and straightforward. Okay, the next question that says, determine the equation of g of x if g of x is equals to f of minus x. Matrix, what does this mean is, if I'm having an equation of f of x, but now the f of x has been changed to be minus x, so wherever you see x, you put a negative x. That will give you your g of x. You just do that. Let's do that. G of x is equals to, remember they said it's f of negative x. Now what does it mean? It means wherever we see x in the equation of f of x, which is given as f of x equals 3 to the exponent x, we are going to put x wherever, a negative x wherever we see x. So that is going to be 3 to the negative x instead of 3 to the power x. And that can be written also as 1 over 3 all to the exponent x. And that became a decreasing exponential graph. That is 1 mark and you could have got it just like that by replacing x value. Okay. 5.3, it's our third question. The third question says, determine the values of x for which f, when they use to the power -1, they are saying the inverse of x is greater or equals to 2. Now, what is the inverse of f of x? Our inverse of f of x, because we are dealing with an exponent, it is going to be the logarithm part of it. So our inverse is going to be determined by a log graph. In other words, our log with base of 3 and x. That will be our equation for the inverse. So they say this equation, if this equation is what? It is greater or equals to 2. So wherever this equation, which is log 3 with an x, it is greater or equals to 2, we must determine the value of x. Remember, folks, this can be written as log of x divided by log of 3. And this is now greater or equals to 2. Now, what are they saying in terms of graph? They are saying if I have the equation of log of base 3 with x, say I've drawn that, and the equation of y equals to a 2, wherever I see my log on top of the y is equals to 2 line, that's where I will get my x value. That's what it means. Now, in this case, if we had to try and draw that log, it will be simply this kind of a logarithm. Let's try to trace it. That is the kind of a graph. Now, what are they saying is, remember this is going to be 1, or the point there is 1. And what are they saying is that wherever you will have line y equals to 2. So y equals to 2 line is somewhere there. If we draw it like that, we'll have the point of intersection. Wherever this one is greater than the log is greater than the one for the straight line, it is whereby we have to get to the solution. So let's check where that can be. Where is it greater or equals to 2 in the graph? If this is the graph that is given to you, remember, folks, the one that is given is the exponent one. So this is f of x equals to 3 to the x. And the one for the inverse, it's going to be drawn from this direction. Can you see that? Now this is our f of -1, x, which is the inverse, is equals to log with a base of 3 and x. Now, if you're talking about the one for y equals 2, it means you'll have a line that is passing through y-axis at 2. So this is the line y equals 2. What they are looking for here is the point whereby the two graphs are intersecting and the log graph is on top of the one for straight line, which is y equals to a 2. So you are looking at this point. If you look at it, that point is far away from a positive 1, so it can be somewhere there, and we need to figure it out. And that is why we are using this to reason with. If I unpack my logarithm and rewrite it as log of x divided by log 3 is greater or equals to 2, I can multiply both sides then now by the log of 3. So let's multiply both sides by the log of 3, multiply both sides by the log of 3. And if that's the case, what is going to be the result here is log x greater or equals to 2 log 3. And that can be rewritten as log of base, log of 3 to the exponent 2. Now, if we look at them, we have log x on the left-hand side, which means that the base is a 10 because it's a normal log. So if the base there is 10, and on the right side we have log of 3 to the exponent 2, and the base is the 10. Bear in mind that 3 to the exponent 2 can be rewritten as what? As a 9. So that means that our x therefore will be equals to 9. Our x will be greater or equals to 9, which means that the point that we are talking about here in terms of graph, it's whereby our x is equals to 9, and everything that is more than that or equals to, it will make the graph of log be on top of the graph of a straight line. So it looks like a very difficult task, but it's not really. It's just need you to be focused and you can get it correct. Okay, the last question on this question 5, it is 5.4, whereby they said, is the inverse of f a function? Remember we had the graph of f, which is f of x equals 3 to the power x. And our inverse is the one which is f to the power minus 1 of x is equals to log with base 3x. Is this one a function? How do we test if it's a function or not? We need to see if our vertical line, it is touching or passing through our graph once or more than that. So if I put a ruler in this graph, move it in this direction, you can see that it is also touching once. So it means that yes, this is a one-to-one function, and therefore this is a function. Because they say, is it a function? You will respond and say this is yes, it's a function, and the reason will be because f of minus 1x, it is a 1-to-1 function. It's a 1-to-1 function. Or the relationship between the two, it is 1-to-1. So it is the 1-to-1 relation, meaning the relationship is 1-to-1. Okay, this was the last question for question number 5.